everyone, this is Erica and I'm going to be doing number 10 in Unit 1 of the Physics C-E&M packet. Alright, so the question reads, assume a water molecule to be a dipole molecule consisting of two charges, a positive electron, positive E and negative E, separated by a distance of 0.04 nanometers, where E is the magnitude of the charge on the electron. Calculate the net torque on a water molecule about its center due to a 500 Newton per Coulomb electric field if the molecule is oriented. Part A, perpendicular to the field. Part B, parallel to the field. Alright, so the first thing I'm going to do is draw myself a picture. So as you can see, what we have here is we have a plus E and a negative E charged particles with 0.04 nanometers in between them. And the electric field is 500 newtons per Coulomb. So part A asks us to find the net torque if it's perpendicular to the field. So that means if the field is going this way, then our particles will be here and here because they are perpendicular, as you can see. Right? Does that make sense? All right. And then the net torque, if this was, let's say, the negative electron, this is or negative charge, and this is a positive charge, then the torque is going to be acting this way for that one and this way for that one. So we can see that the torque acts in opposite directions. So the first thing we want to do is remember the formula for torque. Torque is RF. We also know that in E&M, force equals Q electric field, charge electric field. Alright, so basically we're just going to sum the forces, sum the torques. So every torque equals torque on the positive plus torque on the negative. Right? Okay, so we're going to just plug in numbers. So R we know is 2 times negative 11 meter. This is the radius of the electron. And then we know it's going to be 1.6 times 10 to the negative 19 coulombs. This is a charge of a positive electron, so a proton. And then the electric field, which is 500 newtons per coulomb. Right? And then we're going to add times 2 times negative 11th meter times negative 1.6 times 10 to the negative 19th coulombs, 500 coulombs. Alright, so if you look at the problem, you'll notice that these torques are perpendicular to the electric field, which means that it's in the direction of sine 90 because it forms a 90-degree angle to the electric field. But fortunately, sine 90 is 1. So we're just going to add all these together. And using our trusty calculator, we get the answer of 3.2 times 10 to the negative 27 newtons per meter out of page. Alright, that's part A's answer since it's perpendicular to the field. Alright, part B asks if it's a parallel. If it's parallel to the field, we're going to draw our field again. That means our particles must be like this, arranged like this, right? And then so the torques, the torques would be this way, still the same as these, right? Same torques. But since it's parallel, then any direction is going to be sine 0, which equals 0. So anything you multiply by 0 is still 0. Therefore, the net torque, is 0 Newton per meter. That was simple. Have fun.